So today, first of all, I'll be starting with wherever we left yesterday. I'm in the last class, that is exception handling. So a few of the things were left in exception handling. I'll be covering up those. And then today, the topic which I have to cover is arrays, array list and linked list. That is basically the list, or you can say collection class. I'll be starting with collections class. In that, I have to cover first array list, then linked list, and then one more topic, that is sets. So these are the three topics I'll be covering up. Okay, so let's quickly have a recap of exception handling which we studied in the last class. So I started with giving you a small example where what happened when you don't have any exceptional handling in it, and also we discussed in detail regarding exceptional handling. Let me quickly give you a recap. So I hope you all have gone through the recordings of last class. If not, you can go you can just go through the recordings. I'll just give you a brief idea how exceptional handling occurs in Java. Okay. So what is an exception? Exception is some unwanted event which occur during the execution of a program or code that disturbs the normal flow of execution. So this is a basic definition of exceptional handling. Now, I gave certain examples regarding that, like one of the example is that you are trying to access a file which does not exist, or you have an array defined. Let's say the size of the array is 5, and you are trying to access its sixth element. So that is also something which is out of the range. So you'll get an exception called array out of bound, right? So these were the few examples. If I have to list down what are the different forms of exception, then there are three. One is errors, second is checked exception, and third one is unchecked exception. So when I say errors, errors are something which cannot be controlled by user or programmer, which we cannot cover. Okay, my bad. I guess I've not shared my screen. Okay, sorry. So is the screen visible to all? Okay. So let me again start with it. So I started with exception handling. What is an exception? So what is an exception? An exception is some unwanted event which occurs during the execution of a program or code that disturbs the normal flow of execution. Like one of the example I gave was that when you're trying to access a file which does not exist, so it will throw an exception called file not found. Similarly, when you are trying to access an array, let's say the size of the array is 5 and you're trying to access its sixth element, then you will get array out of bound exception. So it is always important to handle all these exceptions to save your code from irrational behavior. What does it means? That if you are not using any try catch or any way of handling the exception, then your code will come out or will end abruptly, and which will show you irrational behaviors. The mechanism of handling runtime or exception is known as exception handling. Okay, some of the exception occur due to user error, some occur due to programming error. Based on this, we have classified exception into three categories. Those are, the first one is errors, second one is checked exception, and third one is unchecked exception. So when I say errors, errors are something which cannot be controlled by the users or programmers. They occur at runtime due to some uncertain conditions like heap memory get full or overflow, stack overflow occur, or let's say some power gone. So those are the things which you cannot control. That is something related to infrastructure. So that is something which comes under error. Generally, we don't handle these things. Then we have as checked exception. Checked exception, as the name suggests, these are something which are checked at certain point. Okay, so these are the type of exception which can be caught at compile time. Very important. Say for example, you're trying to read a file using file reader class, and at that compile time, your compiler will prompt you to handle an exception called file not found. So these are something which occurs at compile time. And as we are using Eclipse is something which takes care of this compilation while you are writing the code. So for example here, if I put some incorrect syntax, see you're getting a syntax error. It is saying this is an invalid assignment operator. So this is something which is caught at compile time, right? Another example is, say for example here I'm trying to use one method called thread.sleep. Thread.sleep is just to pause your code for some time. So if I say thread.sleep here and give some time, let's say 5000 means 5000 milliseconds. So you can see that it is not giving me any syntax error, but it is giving me some error, some other error. This error is compile time error. If you hover over it, it will say unhandled exception type interrupted exception. That means this particular thread.sleep may throw some exception to you which it is asking you to handle. So that is something which comes under checked exception, which your compiler at the time of compilation gets it. As we are using Eclipse, as soon as you write some command, it will compile your code or at least check for the errors. Okay, so here you can see when I say thread.sleep, that time it checked for the error and it threw one exception to us. So this is something known as checked exception, because here at the time of compilation only you're getting what is the error. Okay, so this is another example, and third example is something where which is unchecked. Unchecked means you cannot get this exception at compile time. They can be caught at runtime. When we say runtime, runtimes mean at the time you are executing your code, when you get some exception, that comes under unchecked exception. Okay, unchecked exceptions are also known as runtime exception and cannot be caught at compile time. They occur during execution of code. Logic errors are also considered as runtime exceptions. Logic errors means, say for example here, a simple example is given. You have an array. I created an int array. Let's say the name of the array is ARR, and the size of this array is 5. Okay, you're assigning the values. As you know that in an array, the value assigning starts from 0. So it will be 0, 1, 2, 3, 4. Now, when you are iterating over this array, then you can see that I started my array from I equal to 0, and I'm going from I less than equal to arr dot length. Okay, equal to means that now this arr dot length will give you a value as 5. So it means it will try to go from 0 to 5, but arr of 5 does not exist. So it will simply throw you an exception. I'll just show you by running it. So right click, run as Java application. So when this code will execute, okay, just a second, why it is coming? Okay, so here you can see that when I executed this code, as the index 5, because arr.length means 5, so it is going from 0 to 5. That means arr of 5 will be somewhere which will be executed, and that is something which is out of this range, because the size of the array is 5 for me, and the values are going from 0 to 5, 0 to 4. So fifth is something which does not exist. So it will simply throw you an exception saying exception in thread main, and the type of the exception is array index out of bound, and it will also give you the message where exception is occurring. So exception is occurring at index 5. Okay, and it also shows you the line number where exception is occurring. So this is something known as stack trace. So this is stack trace of your of the exception which is occurring here. So this is an example of unchecked exception, and this is something which is caught at runtime instead of compile time. Now it is very important to handle all these exceptions, But before we start handling those exceptions, we should know how exception can be classified. What are the different classes available in Java which you can use for exception handling? And then also you should know the hierarchy of exceptional handling, exceptional classes. So the next topic is I'll explain you what are the different classes available, okay, and the hierarchy. So for us, the main type is unchecked exception. The other exceptions, your compiler will prompt you, so you can just read about them and handle them. But the other things, that is unchecked exception, is something which we should know. So exception, if I talk about the hierarchy, so this is the hierarchy. In Java, every class has one of the class as a parent class, and that class is known as object class. Okay, so any class you take, object class is the top class, or you can say is the first class from where the hierarchy starts. In exception handling also, object is the class from where the hierarchy starts. It has some of the methods which Java wants to be there in all the other classes. So every class inherits this object class. Then in the hierarchy, in the exceptional handling, we have something known as throwable. Throwable is something which handles errors and exceptions. So errors are the same one which I was talking in the start. That is something which a user cannot do. So there is a class which has some of the methods written for this error. So that comes under throwable. Then we have exception. In exception, there comes runtime exception as well as checked exceptions. That is compile time exception. So compile time also we are not much worried about. We are more worried about runtime exception. So runtime exception is something which I have mentioned here. Now, runtime exception is inherited by many classes, or you can say there are many subclasses of this runtime exception. Few of them I have listed down here. Like one of them is arithmetic exception. Second one is illegal argument exception. Third one is index out of bound exception, which again is further classified into two. One is array index out of bound and second one is string index out of bound. There is one class cast exception. And if you want to see the long list, this is the long list. These are the different classes which your runtime exception inherits. See, one of them is null pointer exception. This is also important. Then few I mentioned here like arithmetic exception and all. So you can read about them, that what exception do what. Okay, very easy. Just search for Java documentation. Search for Java documentation and you'll get the documents as the first link only. Here search for an exception. Any exception you find, just click on that and you can see here is the hierarchy: object, throwable, exception, then runtime exception, illegal state exception, and whatever I searched. Now, which one I was explaining you? I was explaining you this runtime. So when I click on this runtime exception, you can see that these are the subclasses which are available. Okay, yeah, these are some of the subclasses. If you want to read about any one of it, just click on that and you will be able to. Like file system not found exception is one, and then there is one null pointer exception. So I'll just open it. Then there is one index out of bound. I'll open it. So null pointer exception, you can read about it. What it says. Uh, it says that throws when an application attempts to use null in a case where an object is required. That means you're trying to access one object which is referring to null at that time. These includes calling the instance of the method of a null object, accessing or modifying the field of a null object, take the length of a null, accessing or modifying the slot of null, throwing null as if it was a throwable value. So these are some of the examples. But the main thing is wherever your object is referring to null and you're trying to access it, trying to perform some operation on it, you will get null time exception. Okay, so that comes under this null pointer exception. uh, and then we have index out of bound. Index out of bound, you can simply read up from here. Throws to indicate that an exception of some sort, such as an array or a string or a vector, is out of range. That means you have a range, and that range is crossing. The example I gave you is, in an array you have the size of the array is, let's say, 5, and you're trying to access its sixth element. So sixth element is not possible because array the size of the array is still 5 only. That means you will get a uh, index out of bound exception here. So here, if you see what are the subclasses which inherits this index out of bound, we have two. One is arrays, second is string. So this is related to array, this is related to string. So again, if you want to read about it, just open it and you can read about them, that why this occurs. Like this, there is a long list of exceptions. You can just open that and read about them. Okay, so this is how you will get to know what are the different runtime exceptions are there. Not all are necessary, that it's not necessary that you should know about all of them, but frequently used one you should know, like null pointer, index out of bound, arithmetic exception, illegal argument. These are something which you can read about. Others, when you face an exception, just go and check them. Okay, so this is the hierarchy. Any questions in the hierarchy? Anyone? Okay, so if you don't have any questions in there, let's proceed then. Next is, yeah, next thing is try catch block. So try catch block is where we start handling the exception. Before that, we were discussing about how you will, what are the different exceptions we have. Now we will have try catch, and then we have try catch finally, then we have throws, and then we have throw. So these are some of the things which we need to handle. So first of all, let's talk about try catch, normal try catch. So here we have is try catch. Now, uh, when we got to know that what exception is coming, based on the type of exception, you can perform certain operations. Maybe when index out of bound is occurring, you want to perform something. When file not found is occurring, then you want to perform something else. Right? So there are different type of exceptions which can occur. Like here, I have created a class where I'm writing the logic where an exception can occur in my try. So here you can see, what I'll do. I'll just uh, I'll just copy this logic part. Okay, rest I'll just remove and I'll show you from start. So here I'm writing one try block. So I'll simply say try. Okay, in this try, you can write the logic where which can throw an exception. So I've just written a small logic where I've created an array, and that array has a size 5 and you're trying to access its sixth element. This small thing, small code I have written. Now, uh, after try, you can have something known as catch. Catch block. Okay, in catch block, in the argument, you need to mention which type of exception you are handling. When we saw the hierarchy here, when we saw the hierarchy in the runtime, you can see that we have object, throwable exception, runtime exception, and so on. Then there is a long list. Okay, so here at this particular moment, I'm trying to catch exception. When I'm trying to catch exception, that means whatever comes under it, all of them can be handled here. So if I'm mentioning exception E here, that means I'm catching everything which is below this exception. So exception and below everything can be handled here. Runtime exception or any one of these exception occurs that can be handled here. Now what you want to do with it in the catch block, that's up to you. Okay. Generally, if I talk about what we do in projects, in Selenium projects, so very simple thing. What you can do is whenever you have a try catch, and in the catch block, what you can do is simply call a method to take a screenshot. Okay, in interviews, there is a very good interview question which is asked, and what interview asks is that how can you take uh, screenshot of failure scenarios? So your answer should be that wherever in my all my test cases, I'll have a try catch block. In catch block, you can put this method to take the screenshot. Okay, in our frameworks, what frameworks will develop, there also will do the same thing, where in the catch block will put a method, will call a method which will take the screenshot. Okay, so that's comes under here. Now here you can do whatever you like. I just gave you an example. We'll take care of that in frameworks. Here I'll just simply say system.out.println an exception occurred. Okay, you can do uh, whatever you feel like here, and here you can also do e is the instance of the, here you can see e is the instance of this exception class. So here you can even say e dot print stack trace. Okay, or you can also do one thing, like in frameworks, what we do is in all the catch blocks we have all these errors, whatever error occurs. So this print stack trace will actually print the stack trace for you. And what you can do is you can print this stack trace, whatever you are getting, in your log files as well. Okay, going forward in the frameworks, we'll see how we can enter this information in the log files. Currently, I'll just show you this example. So here you can see when this code executed, first 5 blocks were fine. When as soon as the index went to 5, that is out of range, that time it thrown this exception. Here an exception was thrown and it came out, and one of the catch block executes. Here we have only one catch block which is handling this exception type of exception. And as you know, this exception is something which includes everything. So this exception, uh, that is index out array index out of bound was also handled. Okay, it show you that the exception has occurred at line number 5, sorry, at index 5, and the line number where this exception is occurring is this line number 17. So if you click on it, it will take you to that particular line. Clear? Any questions? Okay, so this is the catch block. Now there can be multiple catch blocks, and it is one of the interview question as well. Interview may ask you this question like this, that can we have multiple catch blocks? You can say your answer should be yes. Then he might ask you what should be the hierarchy of catch blocks. So always remember the hierarchy or the order in which catch blocks can be entered should always be a down to up approach. That means if you're putting a runtime exception, then that should come before exception. Okay, then if you have something like undeclared throwable exception, so then that should come before runtime, before exception. Okay, Nishta, you have a question. What is the purpose of print stack trace in catch block? So that, see, if I remove it and execute the code, you will just get an exception occurred. But if you want to get the complete stack, that from where exception started, going forward, I'll actually show you how to read the exception. That is very important. Okay, but if you want to know from where the exception has occurred and at which line number it is occurring, then you should have this print stack trace. But the thing is, in your real-time projects, we never print everything on console. Rather, we keep them in log files. And going forward, I'll show you how to put this information into log files. But for now, as we are just developing, so we can put it on console as well. So now when you'll execute this code, you will get this information where what exception has occurred and at which line number this exception has occurred. So this is something which is printed because of this e dot print stack trace. Clear? Okay. So moving ahead, as I was telling you that this catch block should be in hierarchical order. So hierarchy should always be from a down to up approach. So here, if you're first of all, if you want to handle index out of bound, then you should have an index out of bound exception here. And in the next catch block, you can have all the others. So for all the others, I'll put let's say e dot print stack trace. I'm not doing anything. So for all the others, I just have handled through exception. If you want to keep it runtime exception, then also you can do like this. Okay, but the thing is, this catch block, as I told you, it should always be from a down to up approach. If you keep runtime exception here, okay, if you keep runtime exception here, okay, then you will see that you will get an error here. What error? If I hover over it, it is saying unreachable catch block for runtime exception. It is already handled by the catch block for exception. As I told you that everything below this exception, this runtime will be handled in exception. So it will saying unhandled, unreachable code. The code will never reach here. This piece of code is something which is not of use. So just remove it. Okay, or keep it before keep it before this exception. Before this exception it will be fine, because whatever exception which will occur as an index out of bound, that will be handled here. Whatever exception occur at runtime, that will be handled here. And if any exception occur outside runtime but under the umbrella of this exception, that will come here. Okay, so this is the hierarchy in which the exception is handled, or you can say catch block should be there. So always remember, it is always down to up. Otherwise you'll get an exception called unreachable code. Okay, so whenever an exception will occur from here, that will go to the catch blocks one by one. Only one catch block can be executed at a time, not all. Okay, so only one can be executed, either this or this, any one of the three. And how it will it be decided? It will go one by one in sequential order. Whatever exception can handle it, that will handle it. Rest others will not be executed. Okay, so this is how it executes. Any questions? Okay, so moving ahead, next we have is there is something known as try, catch, and then finally. Okay, before I move on to that, I'll want to show you one thing. Say for example, here I have a scenario. I want to print something. Okay, when I execute this code, you will see that when an exception has occurred, this statement, that is, I'm after for loop, is not executed. But if the same code, if you try to execute without any exception, you will see that I'm after a loop will be executed. Okay, that means if an exception occurs, nothing after that executes. None of the code after that executes. Okay, now here comes one concept known as finally. Before we jump to finally, I'll try to give you a real-time example where you can use this finally code. Consider a scenario where you are writing a small code of, let's say you are trying to log into an application, then you put an assertion, and then after that you are logging out of the application and closing the browser. Now just consider that you started with this code, and at the time when you are logging in into your application, at that time an exception occurs. Okay, uh, an exception occurs. Now as soon as that exception occurs, your code will come out of that block. So here, when an exception occurred at this statement called system.out.println, your code will come out of this complete logic. Okay, this complete logic, it will come out at that very moment, will be handled by one of the catch block, and the code which is written after that will not be executed because it has come out, it has break that block. So whatever is written after that will not be executed. Okay, one of the catch block will be executed that time. Okay, so if you have written the code in such a way that you log in, you invoke the browser, log into application, and then log out from the application and close the browser. Now just imagine that at the time of login your exception occurred. Okay, so if the exception will occur at the time of login, your code will come out and the statements which are written after that will not be executed, right? So if you have not handled the, if you have not written any try catch, or if even if you have written the try catch block, then also your browser will remain open, right? Because you'll just handle the exception, but you'll not do anything with your browser. So your browser session will remain open, will remain as it is. You have not done anything with that. Okay, that means unnecessary browsing sessions will be maintained. Now to handle it, what will we do? We can simply put a statement called finally. Finally is a statement which will be executed no matter what is the condition. Guys, just give me a second. There is a call, I have to take it. Just give me a second. Okay, I'm sorry. Yeah, so I was telling that at the after all these catch statements, you'll put a condition or put a statement called finally. Finally is a block which will be executed every time. I will be executed every time, no matter what, whether an exception occurs or not. Like in the case when an exception is not occurring, see it is executed. And let's consider the scenario where an exception will occur. Say for example, I put equal to sign here. So in this particular scenario, exception will occur. Now if I execute this code, you will observe that though an exception has occurred, but still that statement I'll be executing every time will be executed. So it's very simple to understand that uh, whether an exception is occurring or not, this finally block will be executed for sure. So this example I gave you from Selenium, where you started with the login and then uh, you have written other statements. What you can do is the closing of the browser you can keep in finally block. Now, no matter whether an exception is occurring or whether the exception is not occurring, in both the cases, this finally block will be executed and your browser will close. So there will be no sessions which will remain hanging in the in between. Every session will get closed. So getting this example, any questions in this? Anyone? So very simple. What you do with finally block? Try is where you will write the logic uh, which can throw some exception. Catch is the block where you can get some exception. Then finally is the block where you will handle the exception. Okay, sorry, catch is the block where you'll handle the exception, and finally will be the block which you'll be executing no matter whether an exception will occur or it may not occur. This will always execute. Okay, so this is a try, catch, and finally. Any questions if you have in this, do let me know. Okay, so as you don't have any question, I'll move to the next scenario, and that is throws. So I'll create a new package for today. Everything else we did in the last class. So I'll create one package with the name day 12. Now in this day 12, I'll create. So the next topic which I'm going to cover is actually throws keyword. Okay, it's a very important thing to understand if you are working on a framework. Okay, in our frameworks, everywhere we'll be using throws keyword. So I'll explain you what exactly it is. So I'll just create a class, and let's say I take one example, maybe throws. I'll just name it maybe uh, login example. I just give it some name, login example. Let's say I'm given the name, and I don't have any public static void main in it. Okay, and in this, let's say I'm writing certain methods. So first method I'm writing is public void invoke browser. Okay, some dummy methods I'm writing. I'm not writing the complete logic, so I'll just simply say invoking browser. Okay, then I create another method. Let's say the name of the method is login. Okay, let's say here I'm writing login to application. Then after login, I'll write, say for example, add customer. Okay, and here we'll write simply adding a customer, and then I'll write the next logic, that is next method, and I'll keep it as logout. Okay, and log out to log out from application. Okay, so these are some of the methods which I have written. Okay, now uh, I'll create another class. Let's say some class maybe on demo login. Okay, I'll keep this public site void main checked here now, and I'm calling those methods one by one. So let's say first of all I'll create an instance of that class. So login example, le equal to login example. Okay, and here I'll say le dot invoke browser, then le dot login, then le dot uh, first invoke login, then add customer, and then le dot next will be logout. So these are some of the methods which I have written. Okay, now just see here, one by one methods will be called. Okay, first invoke browser called, invoke browser was executed. Then next method was this login method was called, and we went here, and in the login, let's say something failed. Say for example, I'm putting a try catch block here. Okay, and this logic I'll write in my try block, and here after this I'm simply saying throw, uh, or let's say let's copy that logic where an exception was occurring. let's say in the login some logic is written which can throw some exception, and here uh, we are simply printing that exception. So I'll just simply say e.print stack trace. I did this, right? Now let me execute this code and I'll show you that. See, when I'm executing this code, what do you observe? See, first of all, it invoked the browser. Then we trying to log into the application. So this was the logic written in login. Just a dummy example because I wanted to get some error here, and it thrown an exception. Right? We handled that exception. After that, if you'll observe, your login has failed, but still you are calling adding customer and then logging out. When your login is failing, that means you cannot add a customer. That means you cannot log out from the file. So is there any sense of calling these two methods when this method is failing? What do you think? What should be your answer in this case? Do you think there is a sense of calling these methods? Or are they not required if login is failing? What I feel is that they are not required if your login is failing, right? If logging is failing, these are not required. So, but if you are keeping your try catch in this way, if if you are try if you're putting this try catch in the called method, see this is a calling method. This main is a calling method, not this one. This main is a calling method because this method is calling other methods. Whereas these methods like invoke browser, login, add customer, they are called methods because we are calling them. Okay. And if you're putting the try catch block in the called methods, like here in the login, you're putting try catch block, then if an exception occurs here, that will be handled here itself. When you'll come back, you'll not have any exception in this case. So your code will go to the next statement. Like the exception occurred in the login, but when the control came back, there was no exception because that was already handled in the catch block. So here at this particular moment, we don't have any exception. So we'll move to the next statement, and next statement for us is add customer. So it will execute the add customer, it will execute the logout. This is what happens if you're keeping try catch in the called methods. There is another approach to this. What approach we can follow is, I'll just copy this and paste it here again. Let's say logging example 2. Now in this particular example, instead of having try catch block in the code itself, you can have something known as throws keyword. Throws and the name of the exception. So let's say I'm putting the exception itself. In every method you can have this statement, and now you can remove this try catch block from here. Okay, so you can remove this try catch block from here, that is not required, and simply add throws exception. Then here also you'll add throws exception, and here also you'll add throws exception. Okay, so what it will do, whenever an exception occurs here, it will not be handled at this particular method, but it will be thrown back to the method which is calling this method. Okay, so for example, here we copy this demo login. So I'll make it demo login 2, and here we'll change it to login example 2, login example 2. And here you can see it is throwing me an error. What error it is saying? When I hover over it, it is saying unhandled exception type exception. That means it is saying you have not handled any exception. So you need to surround this code with try catch. How will you do that? Just select all the lines. Then there is a shortcut, shift alt Z, shift alt Z, and then try catch. Select this try catch. This is one way, or the other way is through right click. So just whenever you have selected, right click, then there is an option of surrounds with, and then you have an option of try catch block. Put it, so that will be get into try catch. Now you can see your code is in try catch. Now when you'll execute this code, you will observe, okay, now when I execute this code, you will observe that once this login occurred and an exception occurred there, the other two methods were not called, because in this case the exception has occurred here. So in the login the exception occurred, and that exception was handled by this catch block. Okay, so the other two methods will not be executed. And it makes sense as well that once you are invoking a browser, then you are logging in. After that, you want to add a customer. If your login has failed, no reason to call add customer. So it should stop then and there only, move out of the code. Clear? Any questions in this? Anyone? So no questions here. Good. Then I'll move to the last thing in this. So we are done with the throws keyword as well. So now you know throws keyword is something which, instead of handling the exception in the calling method or called method, sorry, in the called method, you will be handling in the calling method, so that we can run only those things which are required. Unrequired things can be taken out if an exception occurring. Okay, so this is all about throws. Next we have is uh, throw. That is the last thing, and interviewer might ask you a difference between throws and throw. So I hope throws is clear to all. Now let's talk about throw keyword. So again, very simple thing. Throw is throwing a customized exception. Here, wherever we throw any exception till now, that was not a customized exception, that was something which was written in your code. Okay, you are not uh, you have not defined any exception, but if you want to define an exception type of your own, then you can use this throw keyword. Okay, so say for example here, after maybe somewhere we can put this condition. Say for example here in this add customer method, I can put this condition. If, let's say, I take two number, int x comma y, and I assign some value x equal to 10 and y equal to, let's say, 20, and I'm saying that if x is greater than y, uh, I don't like this condition, so I'll simply say throw new exception, and in the this you will mention what is the exception. X should not be greater. So this is to send some customized exception which is not there in your code and you want to handle it. So I'll just make my code in such a way that now add customer will throw an exception. So when I'll execute this code, you will see add a customer. After that, what happened? Add a customer access. Okay, uh, I have to put the other condition. Okay, let it be same, and let's change this value to 100. Okay, so when I'll execute this code, what error is there? Okay, my bad, I should execute from here. So here you can see add customers is throwing an exception, and the message is here, x should not be greater than this. from where it is occurring. It is occurring from, see here, you always have to read from down to up. It is occurring from demo login. So if I click on it, that means it is coming from here. Just above it, it will also give you from exactly from where this is coming. So this is the way you will read your exceptions, and this is the throw keyword. So throw keyword is used to throw some customized exception. Any questions in this? Anyone? Okay, Shubhanshu, I have a question. It is mandatory to use throws keyword in called method while surrounding the method with try catch block. Uh, See, it's very simple to understand. You will have throw keywords wherever you don't want to handle the exception there. Instead, you want to handle in the last or the calling method, the method from where the execution is starting. Then here you will have throws keyword, but wherever you're calling these method, there it's mandatory to have try catch block. You can say that try catch is must. It should be there at the end, at the last one. Okay, so the last one for us is main only. In the main method, it is mandatory to have try catch. Otherwise, you'll not be able to handle the exception. From other methods, you can simply throw. Did I answer your question, Shubhanshu? Okay. Any other questions, anyone? So if you don't have any other question, we are done with exceptional handling. Next topic I'll be starting with is lists, basically the collection class. So yeah, let's have a break for 5 minutes, 7 minutes, and then we'll start with the next topic. Uh, Priyanka, you have a question. Can we use try catch in called and calling? Yes, you can use in both the location, but the thing is, in the called method, that means here, uh, here only, here only everything will be handled. So none of the exception will go here. You can have a try catch block in this also, but it will never be executed because all the exception will be handled in the individual methods. So you can have a try catch block here, but the exceptional handling will happen within the individual method. So you'll never get any exception in this particular block. That is what I mean. Okay. Yeah. So let's have a break for some time. Let's say 7 minutes, and I'll see you after 7 minutes. We'll start with next very important topic. Okay, so we can continue again. Any questions before I continue from here? Okay, so let's start with the next topic, that is data structures. Okay, and what all you need in Selenium, that's what I'll be covering. Okay, so what is data structure? Data structure is the different structures of data, the different structures in which we can handle data, big data, basically. In C language, if you remember, we studied about abstract data types. Then ADT, we used to call that. We had that linked list, array list, and so on. In Java, what happens is, like in the C language, if you remember, we used to create our own ADT methods, and then we used to proceed. In Java, everything is given inbuilt. So there is a class called collections. Collection class is there, which has different forms of structures available with us, data structures available with us. So if I want to classify this, then this collection can be divided into one as list, second is set, third is queues, and fourth is vector. So when it started, it had these many things. Out of these, queues and vectors, they are obsolete now. Okay, so we will not be studying queues and vectors. Both of them are obsolete. We have list and sets. So mainly our focus will be on lists and sets. So if I talk about list, in list we have two. One is array list. Okay, this is what we are going to study. And next we have is linked list. Okay, so this is what we are going to study. Now, if I talk about um, sets, so in sets we have two. One is one is normal hash set, second is uh, linked set, and third one is tree set. So these are the three which are available in sets in Java. All the three has their own some uh, mm, I mean some special things which I'll discuss. Now, along with this collection class, there is something also important, which is maps. Though maps are not used much in Selenium, but still I'll be taking them up. Okay, so in maps we have three things. One is hash map, second is linked maps, and third one is tree map. Okay, so these maps actually are not a part of collection class, but they are always studied along with collection. So because they are some similar kind of implementation, they have simply similar kind of implementation, and they are similar to understand as well. Not from collection class, but studied with it. So these are the things which I'll be covering. Okay, so quickly if I give you a recap, we have a collection class which has four things: list, set, queues, and vectors. Queues and vectors are obsolete. They're not used now. So we have list and sets. So list we have two, array list and linked list. Then we have sets. Sets we have as three: hash set, linked hash set, and tree set. Then we have maps. Maps has three: hash map, linked map, and tree map. Okay, this list is an interface, whereas array list and linked list, these are classes. So this is also a class, and this linked list also a class. This is an interface. Okay, these are again, all the three are classes. Okay, so this is also you have to remember. Then again, map is an interface. interface, and the other three remaining are classes. Okay, so any doubt till now, anyone? Okay, so let's start with the list then. And before we jump into what is a list and how it works, I want to first discuss one problem, then we'll jump to lists. Okay, the problem is we have something known as arrays, right? I can create an integer array, arr, equal to new, let's say int. I give some size. What do you think is the problem with this type of data type? What do you think? What could be the problem with this data type? We have this data type arr. I created an array arr which can store 10 values. Okay, so what is that problem we have that we came to list? What
Arrays
would
are
it?
fixed in size.
Yes, arrays has a fixed size. If you're defining the size of array as 10, you can have only 10 values in it. Let's say if you want to store the 11th value, then you have to create another array, or you need to increase the size of this array, right? So the size of the array is a problem. Maybe you started an application where you had to store some 10 values, okay, but as soon as your project started, it started increasing. Uh, you you I mean, your project started increasing. You got to know that 10 values are not enough. You'll create another array of bigger the size and then store those values in that new array. Right? This is what you're going to do. Okay. So this is one limitation with this array, that the size is something which is a limitation. If you don't know what is the number of the array, then you just have to go with your prediction and proceed. Okay, so to solve this issue, uh, Java created two different data structure. One is array list and second is linked list. Okay, they have actually came from the abstract data type which was studied in C language or C++ language. What we did in this particular thing is, see, uh, what happens is, let me just give me a second. Yeah. So what I'm trying to explain here is I'll create one, see here, sorry for this bad diagram. What is this list? List is like a container. It's like a container which has some block in it. And what you can do is you can put as many values as you can. You can start storing values in it. Okay. Now, what was there when we had an array? Okay, in array you created an array with some fixed size, right? Let's say I created an array and the size of that array is fixed. Let's say it has some five values. Okay, and I started storing values in it. Let's say one value was stored as 4, second was 3, then I entered 2, then I entered 1, and then 4. Now this array is filled. If you want to fill this fifth value, what you'll do? You will create another array, right? You will create another array of double the size or maybe bigger the size. Generally, what is practical is people create an array of double the size. Okay, and then move these values to this. You will put 4, 3, 2, 1, 4, and you still have another 5 blocks available where you can insert the values. Right, now just imagine that this also gets filled. Then what you'll do? You have to create another array of double the size and then you'll do the same thing. Right, this is what you'll do. So this array list what we have, okay, this array list what we have here, uh, this is a kind of, this has a same kind of implementation. It is like a container which stores value for you the size does not matter. It will store as many values as you think of, but how its internal implementation goes, it will be like, if I just remove all of these. Okay, just a second. How to remove? Yeah. So if so when you create an array, it will be like this array list. Then in the angular brackets, you will tell what is the data type. So I'll give you the complete syntax. Then let's say I created one array list equal to new array list. This is how you will create. Okay. Now here, see, nowhere I've mentioned what is the size of this array, right? So what will happen internally as soon as you create this statement where you say array list of type integer array list, you create this, what it will do, it will create an array of some default size. Generally, what I have observed is, I'll also show you that that size which is created initially is always a size, always equal to 10. I mean, the size of the array will be 10. Okay, it internally creates an array of size 10 where it will start storing values. Okay, as soon as this array will fill up internally, where you will not even look, or where you will not even get to know that once this array will be filled, once this complete array will be filled, it will create another array. It will create another array of double the size. Okay, and will have will copy the values from this to the new array, and you can again start adding. Then let's say this another array is also filled. Then also what will happen, if you have to add another value, it will create another array, third array, with even double the size, and will start storing. And the older arrays, it will keep on removing. It will just dim what you'll call destroy this older array. So that is how an array list works. All these things happens at the back end. You'll not even see these things happening. Okay. uh, Clear with this? Any questions in it? Anyone has any questions on how array list works? What is the implementation of array list? Okay, then I'll show you same thing through the code. Now I'll go to this, and let me close all of this. Here I'll create one class, and let's say I'll call it array list example. Okay, we'll keep this public static void main checked here. Yeah, so in this particular class, what I'll do, I'll create one variable. So the name is ArrayList. You have to take one from the class called java.utils. This is the class which has the implementation of ArrayList. So select this. Here you need to give the data type. Just one more thing. The data type which it takes is not the primitive data type, but it's a non-primitive data type. Now what is the difference? The normal primitive data type, where we were storing the values like small int and the name of the variables, and then we used that thing to store the integer value. What is the difference is, that is that int, that int int is a primitive data type which does not store values as an object. They are just some memory, some variable where you can store. But this integer, what you see here, it's a class. When I hover over it, read about it. The integer class wraps a value of the primitive type int in an object. An object of type integer contains a single field whose type is int. So it's quite similar to that. It's a wrapper class, but it provides us many more features which you cannot perform directly. Like one of the example is if you want to convert an integer to string or a string to integer, then we have this we have a method called integer.parseInt. What it will do, it will convert your string into integer. So that is something which we achieve using this method, this class. Okay, and this array list takes this as a variable. Okay, now here I'll create a variable called ArrayList equal to new ArrayList. Okay, so see here, nowhere I mentioned the size of the array. Now I can start putting value in it. How to put value? The method is add. Add. Now add is a overloaded method. Look at here. This add, if you see, will be an overloaded method. There are two methods. One is add with one argument, and then there is an add with two arguments. So what is the difference? If you're using the first one, that is add with single argument, here it expects some value. What it will do, it will always insert a value at the end. Okay, so whatever will be the array, whatever will be the array list, in that it will start adding value at the end. Okay, say for example, if I have this and if I add these values, so if I run it, let's say 13, 14, 15 and 19, if I do this, you will see uh, for the first time this array list will be an empty array. It will not have anything. Then in that the second uh, when this line will execute, at that time it will have already existing a value, that is 12. So it will add this as this at next number, this will add it next, and so on. Okay, so if I show you, if let's say I say system.out.println, and to get the value array list dot, there is a method called get. Here you have to give the index. So this will be like the first value will go and store it at the 0 index, second value will go and store at first index, and so on. So if I give index as 3, what do you think which value get print? This is 0, 1, 2, 3. That means 15 will get printed. So if I execute this statement, 15 getting printed. Okay, now the second method which we have for add, for that I'll want to give you an example first. See, if I talk about something known as insertion, what happens when you have to insert something? Let's say you have an array, a normal array or an array list, it does not matter. Here let's say you have some values 4, 3, 2, 7, 1, and let's say you want to insert one value 5. Okay, at index as 2. At index 2 you want to store this value as 5. Now the index for this is 0, index for this is 1, index for this is 2, and this has an index 3, 4, right? This is 5, this is 6, and so on. Now I want to insert at index 2, that is this, I want to insert 5. But this value already have a 2. I'm saying insertion, I'm not saying overriding. Okay, so I want to insert the value at second index. First I have to make this space empty. To make this space empty, I have to move every value one ahead. So I'll move this one ahead, then I'll move this 7 here, and then I'll move this 2 here, and then this value can be inserted, right? So this is insertion in an array. Okay, similarly, is this clear? Is this insertion clear that what is happening, that this value is moving one ahead, then this is one ahead, then this is one ahead. So the value insertion at the end is just like adding at the end. So this method what you see here in this particular thing, in this particular thing, if I remove everything, if you see in this particular thing where we have uh, this add 12 or add 13, they are like insertion at the end. So they will get inserted, at the end every time. So they are very quick. But if you're calling a method where you are saying array list dot add, and then you're giving an index, let's say at second index I want to insert, let's say 78. Okay, and if you want to uh, okay, my bad. If you, and here if you want to print what is there at second index, if you execute this code you will see that 78 got printed. Okay, so what it did earlier, at second index 14 was there. So if before inserting this 78, if I execute this code, you will see 14 is printing. So what happened, it was at 0th index, this was at first, second, third, fourth. When you inserted 78 at second, this will go to one next, this will go to one next. See, earlier when we were executing this get 3, 15 was printing. But now if you'll observe, 14 is getting printed because every value moved by 1. So this is second way of inserting. Clear? Any questions? Okay, now I have a small question for you. What do you think? Insertion in the start or insertion at the end or insertion in the between? Which will take the most time? Which will be the slowest operation? Insertion at the start or insertion at the end? What do you think? Anyone? No answer. I'm okay. So Sai, you're saying at the end will take more time or less time? My question is which one will take more time? Okay, you're saying at the end will take more time. What about others? Actually, it is other way around. At the end, it will take less time. At the start or at the in the between, it will take more time. Yes, yes, Sai, it is other way around. See how. Uh, I'll just see. When you have to do it in the end, what will happen? Let's say this is an array. Okay. Let's say this is an array. I have some value 4, 3, 1, 4. These are the values which are already inserted in it. Now, if you have to insert at the end, new value whatever will come, let's say you want to insert a value 5, new value whatever will come and get inserted here because that space is already available. Now, if you have to insert anything in between, what will happen? Let's say if you want to insert anything at second index, let's say 6 you want to insert here. So first that you have to first make this place empty. Let's say 5 was inserted. So for that first you will move this 5 to this, then you'll move this 4 to this, then you'll move this 1 to this, and then this will insert. So to perform only one single operation, that is insertion at the second index, it performed how many operation? One moving this, two, three, and then four. That means four operations were executed, right? So as four operations were executed, it is a slow operation. Similarly, the same thing at the start will be too slow. So this is one of the limitation we have with array list. Okay, clear? Any questions, any doubt? Same is the case with deletion. It's not insertion, but same is the case with deletion as well. If you're doing deletion, Then also it will take time if the deletion is in the start, and it will take less time if deletion is at the end. Okay, so if I list down why what is there with this array list, then um, one thing, internally it handles like an array only. Okay, so it will create one small array of default size 10. I'll show you. Let me just put a debug point here. Right click debug as Java application, and you will see, let it open. You will see that a variable with name ArrayList is created. See the type, it's an ArrayList. If you open it, uh, sorry, if you expand it, you will see the size is 5 because only 5 values has, where is it? Yeah, uh, because till this, because till this statement only 5 values are inserted till this, and if you open it you will see that, see the size 0 to 9, that means a very this array list was created with the default size as 10. As soon as these 10 values will get filled, when it will try to fill the 11th element, it will create another array with some bigger size, will copy these values to the new one and start filling the other one. Okay, and even the thing is, you'll not observe any of these things. All these things for you will be normally putting values in a container. Okay, a container of infinite size. That's what you will observe. Clear? Any questions? Okay, so moving on. Next thing what we have is, yeah, so here you can see these 5 values are printed, and now when I insert, so look at here at the second index we have a value. If I open value is 14. Okay, so when I execute this statement, you can see how many values got changed. Look at here, the size of the array got changed to 6, the value at second index got changed to 78, the value at fifth index was null earlier, now it got changed to 19, this got changed to 15, this got changed to 14. So one operation here, and then this space was empty, and then insertion happened. Right. So this is how array list works. Any questions in this? Okay. So this is one limitation with an array list, that it consumes times when it comes insertion in the start or in between. It is quick when the insertion is at the end. So if I have to list down when to use array list when data size is small. When data size is small, then you can use array list. Then if you know that insertion or deletion is less in start, okay, or the same thing, but what I'll say, insertion insertion or deletion is more at last. Okay, if these are the scenarios, then you can go ahead with array list. Okay, then I'll come to the next one, that is linked list. Let's discuss about linked list. What is the benefit of using a linked list and how it solves the problem with array list. So for that, uh, what is a linked list? As the name suggests, there is a link between the list. Okay, so in array list, if you observe, whenever I was giving you an example, that array list internally creates an array. and array is always something which can be stored in a continuous memory location, right? So this linked list, they are not stored in a continuous memory location, rather they have something known as nodes. That node has two parts, one where values are stored and second where address is stored. Address of what? Address of next memory location. There is something known as start or top. You can call it top. Top is the one which only has memory address of first node. Okay. Say for example, it is storing an address 2004. So 2004 is the address of this particular block. Okay. And then let's say it has some value 43. Okay. Now let's say you want to add another value. When we have to add another value at the runtime, JVM will create another node, okay, where which let's say is stored at 4008. This is the memory address of this. So this memory address will get stored in the memory block of first node. Okay, so it will start linking to this. Now here whatever value you have, let's say you have a 6. Okay, like this, every time you add a new value, it will store like this. Okay, now comes the other thing, that when we have to do an insertion, which was the limitation for an array list. Let's talk about that. Let's say you want to insert something. Now this will be at 0th index, right? This will be at first index. Now if you want to insert anything in between these two or at first index, what will happen? See, when you have to do an insertion, it will create another node. That node, in that node, it will store the address of this location. So it will store address of 4008. So that means this is also pointing to this. This is also pointing to this. This is also pointing to this. Now, here, let's say you want to insert 7 in it. This is the node. Now, what you have to change? You just have to change this address to the new one. Let's say the address of this is 6000. You just have to change 6000 here. This will start pointing to this, and here this link will be gone. Insertion happened. Now, how many operation happened? Only one. That is, the address from here was stored here and the address of this was stored here. That's it. Nothing else. You have not moved one out, and so the time consumption in case of linked list is way less than array list. And it does not depend where you are storing the value, whether you are storing at the end or whether you are storing in between or whether you are storing or inserting at the start. Okay, so insertion at the start, in between, or at the end will take exactly same time, and it is way less than array list. So when will you decide to go with linked list? Before that, any questions here? Okay, Nishta, you have a question. If we have not, if we have to do insertion at the end of array list, then we have to mention index or not? No, you don't have to mention index if you every time you want to enter at the end. No index is required. Just give the value, it will always insert at the end. Okay, so any questions here? Okay, So let's discuss further. So if you see, where I was, yeah. So I'll give you example of linked list now. See, when you're working with array list or linked list, for you, there is no difference. Difference is in implementation. When you are, I mean, difference is in internal implementation, the way they work. But when you look at uh, how you call methods and what are the different methods available in it, there is no difference. See here, when I say, when I have to create a linked list, I'll say linked list. Okay, I have to change the name of the class. Just give me a second. I have named it exactly same, so let me rename it. Right click, refactor. Where is refactor? Rename. I'll change it to linked list example. Okay, so here I'll say linked list one from, you have to take one from java.utils. Here also you need to tell the data type, and let's say here I'm saying linked list equal to new linked list. When you start inserting values and everything, they are like same. Add like 45. So again, the insertion will always happen at the end in this case, and so on. Okay, so insertion happened exactly the same way. So here if I say system.out.println, I want to get value from linked list dot get value you want to get at sixth index, let's say, not six, third index. Okay, so when you execute this, you'll get the same value. Similarly, if you'll add the values with an index, let's say you want to insert something at second index, what, maybe 89, then it will get inserted at the second index. So if I execute it, 89 is coming. Okay, so same statement before this insertion, if you'll execute, you'll get 58 because 58 is at second index, and with that you do, then also you will get the same value, I mean the other value, that is at 89. Clear? Any questions? Is the way implementation of linked list is there, is it clear? Okay, so when you have to decide with which to go, in case of, this is for array list, for linked list, what you'll decide when data size is large. Okay, while like why when large, then use this. See, when we have to use linked list, okay, I have to, just to store one value, I have to take two memory locations. Let's say I want to store six. Just a second. This is one node I'm creating, and I want to store some value, let's say 7. Then I also have to create another to store the address of next memory location, right? That means just to store one value, you're wasting two memory locations. So if your data size is less, then you are using double the memory location. Whereas in case of array list, you will have a long array where only one value will be used, right? That means when this array size is small, okay, this takes less value, whereas this takes more value. But when it comes to millions of value, see, when you have to store million value, and let's say you want to store 10,000 value, and as soon as you added one more value, 1,000,001, what will happen? And let's say your array list get full that time. what will happen? You will create another array of double the size where all the memory location will be continuous. Then it will consume lot more memory. Whereas here, when you have to add one more value, you just need two blocks. Whereas what I mean was, let's say you have some values in it, maybe this 1, 2, 3, 4. Let's say this is at 1 millionth location and it got filled. Now I need to insert one more. When you have to insert one more, then you need another array of double the size where first these value will be moved and then a new memory location will come where you will insert the next value, right? So this array list, when the size is too high, they consume a lot memory. And another limitation is in array list it has to be a continuous memory location. Okay, so a, a scenario may occur where your memory location may go out of space. I mean, continuous memory location is not available. Okay, so in that case, linked list works better. So this is one way, one thing. Any questions here? Anyone? Okay, so you're saying, Sai, question is performance is better in array list as it has a fixed memory size. Performance is better in linked list, as I told you. Performance in the sense when insertion and deletion you're talking about, then it is better in linked list. If you're talking about get, then yes, array list has better performance. So if I talk about insertion and deletion, then linked list has a better performance. If I talk about getting the value, then yes, array list has a better performance. Got it? Yeah. So this is all about linked list and array list. And if I talk about what else, so as I told you, data size is large and insertion deletion is more. Okay, then this takes less time. Yeah, so these are few points which you have to remember. Okay, another thing is iteration over an array. So that is something which you should know. Then how to iterate over an array list and linked list. For both, the way is quite similar. Here also, I'll be using enhanced for loop. That is the best option. So here, first of all, you'll take the data type. So the data type is integer. Then create a temporary variable. Let's say temp colon name of the linked list. So here it will be linked list. Now just like a normal for loop or this enhanced for loop used in arrays, here also values one by one will come from linked list to temp, and then you can use that temp variable to store the value. So for example, here I'm saying uh, temp, it will execute and print all the values. So here you can see it executed all the values. So this is how you will do iteration. Okay, so we have discussed a lot about this enhanced for loop. Only thing changes here we are using um, the non-primitive integer, that is integer class, because the data type of this linked list is integer, and rest everything will remain same, nothing changes. Clear? Any questions in this? Okay, fine. Yeah, so what else? What else we have to cover? Yeah, I guess this is enough for today. We have discussed about array list, we have discussed about linked list. Yeah, we can look at other methods available, though they are very less used. I mean, I've never used any other methods, but yeah, you can see if something interests you. Like one is the size. Size is something which we use. What this size means what is the size of the array, how many values are there in that array. Contains to check whether a particular thing is available in that array or not. Then we have is empty to check whether an array or linked list, whatever you're calling, is empty or not, and so on. So there is a long list. You can go through these methods if something interests you. Okay, one more thing. As I told you that there is a in, when we started, we discussed that this list is an interface, and there are two classes, array list and linked list, which implements this list. Okay. Okay, so here when I'll be creating the when you create this, you can also change it to list instead of list. You have to take one from java.util. You can change this also, because this list is an interface and its implementation is there in either linked list or array list, just like we discussed about interfaces. Okay. So yeah, that's all for today. Tomorrow, what we are going to cover, first of all, I'll cover few things, few scenarios remaining in this array list and linked list. Like I'll show you how array list, when insertion happens in the start, how it takes time. Then how when insertion happens at the end, how it takes less time. This is what we will see. Next, what we'll do is we'll cover sets, and then we'll go to maps. So these are the three things planned for tomorrow. After that, once this is done, most of the things in Java will be done. Then we'll move to the next topic, that is Selenium. There are many more scenarios which are left in Selenium, so I need 2 or 3 classes for Selenium, and then we'll start with TestNG. So that is what is planned for future. Okay, so I'll stop the recording now. I don't have anything for today.